A constant that shows up all over the place in math and physics is pi, written like this. It is the ratio of the circumference of a circle to the diameter. The circumference of the circle is the total distance around the circle. Also, like the perimeter, but it has a special name, the circumference. Now, when we talk about the diameter, it has to go through the center, and it's any line all the way across, so it can go in any direction. But for simplicity, we just do like that. The radius is like the diameter, but it is only half. It only goes one way, not all the way. That would be the diameter. That would be the radius. Simple stuff. There are many neat methods for calculating both the circumference and the value for pi, but those might be a little bit too much. Pi is approximately 3.14, 15928, and it goes on forever with no particular pattern. It never ends, and it can never really be written as a fraction. Well, I mean it can, but yeah. It shows up all over the place. One very specific example would be to find the area of this circle. So how much area does this take up? And the area would be pi r squared. And, if you just have let's say the radius now is just 1 meter, that would just be pi meter squared, or 3.14 meters squared. Pi will show up basically in all sorts of geometry problems, anything with the periodic function, like sines, cosines, and really anything dealing with angles, it will show up. Another constant that shows up a lot is known as Euler's number, or just simply E. E. The very basic definition for this is this behemoth. Basically, if we plug in larger and larger values for n, we're going to get a closer and closer value for what E is. That E looks ugly. Let's rewrite that. There we go. That's still kind of ugly. Anyway, if we say, like, for example, n is equal to 1, it's not really interesting, but it is just, I don't know. Say n is equal to 2. We're getting bigger values. Now, if we go to 10, this will give us a even larger value, even closer to what we want. But after a while, these should all be approximately. It gets closer and closer. Well, actually, no, that one is equal. It will get closer and closer to E. And we know e to trillions of digits already. Like, they have supercomputers that can calculate this as the n goes to larger and larger values, insane large values. But oops. E is approximately 2.718, and like pi, it goes on forever. Decimal goes on forever. It has no pattern, really. It just keeps going on forever. There's no way to write it as like a fraction, a over b or something like that. And this is known as like a natural number. It's used it's used a lot. It's insane how often it's used. It's used for exponential functions, like e to the x. It's the base for this. This is, right there. And it's also natural log of x. You'll see this a lot too. This is just basically the log base e of a number. And this also shows up quite a bit. So it shows up in like growth rates. Say a is equal to a naught e to the rt, or it could be like a decay, like a population decay, something like that. And surprisingly, it also shows up in complex numbers, which also, in a way, could be used for geometry and periodic functions. But like e to the ix, if we use x is equal to pi, that just gives us -1. And I'll explain all of that some other time. Thanks for watching.